All right, so we're going to look at lesson 5, scatterplots and lines of best fit. So the first thing that I'm doing here is mounting my Google Drive. So I did that for the lesson 5 notebook. But on here, we have some data that is, if you look at technology, teacher took 3 samples of practice time typing, so how many practice hours you did, and how many words per minute that you did, and they did 3 different samplings. So what trends do you notice in just the tables? So as the practice hours increase on the first table, it looks very much like also the words per minute increase. Same here, sample 2, the practice hours are increasing, but these numbers are jumping up and down. So there's more in sample 2. Sometimes the hours are going up, sometimes they're going down. It's not an exact linear pattern, and neither is this. This just, they're going up more consistently. And then in sample 3, same thing. You see they're jumping up and down. So what trends do you notice? Just say as practice hours increase. The words per minute seem to increase. And that's easier to see in the actual table. So how easy is it to see trends in the table? So really it's not as easy to see trends. Um, so it is easier to see actual numbers than trends. So here's the scatter plot. And as I'm looking at the scatter plot, you can see as practice hours increase, so do the words per minute. The graph is going up from left to right. It's not perfectly linear, but if I drew a line between there, all the points would be pretty close. Here, if I drew a cloud of points, you could see the line would kind of go through there and be increasing. Here, you can't really tell. There doesn't seem to be a noticeable trend. So I just kind of explained that verbally. So you can see sample 1 shows an increasing pattern. Sample 2, a little bit of an increasing pattern. Sample 3, it's hard to tell. So it's much easier to see trends in scatter plots because you can see that visually. So now on here, you're going to draw this. So you're going to plot the practice hours and those, and then you're going to draw a line of best fit. And then you're going to pick 2 points on the line and then use that to find your slope and your y-intercept. So the y-intercept would just be what number does it cross the y-axis at, and then what is the actual slope. So I'll leave that to you. Here, the equation for the line of best fit is y equals 4.56 x plus 5.11. Use it to find the words per minute if you practice for 3 hours, 7 hours, and 10 hours. So here what you do is go 4.56 times 3 plus 5.11. And I'm going to grab a calculator right here. Let's go ahead and do that. And you get 18.79. And on here you go 4.56 times 7 plus 5.11. And that's 37.03. And then lastly for 10 hours, so 4.56 times 10 plus 5.11. That gives us 50.71. So if you practice for 10 hours, about 50 words per minute. Now, really, that's going to kind of vary. At some point, the number of words per minute is you're going to level off. So what if you practice for 11 hours? So if I practice for 11 hours, and remember, no one practiced for 11 hours, you would get 55.27 words per minute. And then is that contained in the data set? So if I go back to those tables, no one actually did 11 hours. So 11 hours is outside of the data. But the estimate seems valid. And then what this is called when you use that to predict the future a little bit, that's called extrapolation. So we're using that to predict future values. Now, the thing is, when you're using that to predict future values, you might not be as valid as you think. So what if you practice for 80 hours? So 4.56 times 80 plus 5.11. I should be able to type 369.91 words per minute. And that's pretty much probably impossible. So the estimate, it doesn't seem valid. So what if your goal was 50 words per minute? So what I would solve is 50 equals 4.56x plus 5.1. So what I would do there is subtract 5.11, so 50 minus 5.11. And when I do that, I get 44.89 equals 4.56x. And I can divide that by 4.56, and you get 9.84 about equals x. So that's approximately. So the answer would be 9.84 hours to get that unit. So you'd have to practice that long to have that many words per minute. So now you're going to learn how to draw some scatter plots and then also find the line of best fit. So I'm going to go through the code there, move this. So I'm going to import the libraries. Remember, even your computer program needs to go to the library to know how to do this. I'm mounting my drive, so I'm going to import the file for lesson 5. So this is one variable statistics with Python, and I need to go to lesson 5. Oh, I'm sorry, this is actually 2 variable. So let me go to the 2 variable statistics, and then lesson 5, scatter plots and lines of best fit. I'm going to copy the path for that and put that path in here. And then what I did too was drop the NA values. So words one, I did just this. I imported all the data. I made a separate data frame with just the first sample. So words one was lesson 5 data, practice 1 hours, and then words per minute. And then I dropped the NA values. The reason is there were not all of the values were of the same length. So when you do that, you have some NA values. So to do that, it would have like 14, 15, 16, and then have NAs. So that just gets rid of that. So this is a code here. I did PD data frames transpose of word one that I used to make the table. And then what I'm going to do here is make the scatter plot. So I did a plot dot scatter of on the x-axis practice hours, comma, on the y-axis words per minute 1. And then I gave it a x label and y label. And then to do that with a line of best fit, what I did was called x words 1 of practice hour, y words 1 of words per minute. I use this line of best fit by going np, it's in the NumPy library, polyfit of x, y, and then 1. And then I did a scatter plot of x and y, so it'll do the scatter plot. And then I'm going to plot x and ax plus b, and that plots the line of best fit. So there you can see the line of best fit is plotted in there. And that just goes through the middle of the data frame. So now what we're going to do is create words 2, which is just the second sample, and then drop those NA values because not all of the data in the Excel file was the same size. Then I did the transpose of that. And now when I put in the scatter plot, you see what I got there. But now what I'm going to do is put in the scatter plot with the lines of best fit. So I defined the X to be practice hours, the Y to be words 2 of words per minute. And then I did this polyfit of A and B. So np.polyfit of X, Y, and 1. And then I did the scatter plot of X and Y. And then I plotted X and then AX plus B. And if you notice, that draws in the line of best fit. And you notice the points are a little bit further away. This we call this a correlation. It's not as close, so the correlation isn't as strong between practice hour and words per minute in this sample. But it's still positive because the line is going up. So the second one, what we're going to do is practice hours 3. Then I did show like words 3, where I did the practice hours and the other ones. And then I did the transpose to make the table. This does the scatter plot, doing the X and Y does a scatter thing. And then here I did the words 3 of practice hours and the other part to fit in the line of best fit. Now, if you notice, this line of best fit is like the points are very far away and it's hardly even going up. This is hardly any correlation or no correlation. So task 2, I made a blank scatter plot by just going practice hours, words per minute. I did an X limit to go from 0 to 10 because we had 0 to 10 hours, and then the Y limit to go to 0 to 50 for the words per minute. So now what I'm going to do is have you work on the practice problems. So I'll let you struggle with this a little bit and go through those, fit in your own code, plot all those, and then do that, and then also do the check for understanding.